This is EL6303 Homework 10. And this video is about problem 1. Let's see the question first. It has to collect the definitions and sample properties, like probability masses and or density, mean and autocorrelation function of the examples of stochastic process. And the first one is Poisson process and Poisson increment, Poisson impulses, semi-random telegraph signal, random telegraph signal, random walk, and the Wiener process. And we also need to explain the understanding of the process. So let's see, the first process is Poisson process. The definition is that the number n t1, t2 of the points in time ti in the interval t1 to t2 of the length t equals to t2 minus t1 is a Poisson random variable with parameter lambda t. We have p, the probability of n t1 t2 equals to k is equals to e to the minus lambda t to the k over k, and define the Poisson process xt as x0 equals to 0 and xt1 minus xt2 equals to the number of cells received in t1 to t2 with the probability of t1 minus xt2 equals to k. The probability of this is equal to this. And at a moment t, there is no more than one Poisson point, and the points in non-overlapping intervals are independent. Let's see the properties. The first order probability masses is the probability of xt equals to k is equals to e to the minus lambda t to the k over k, and the mean of the Poisson process is lambda t, and the autocorrelation is r t1 t2 equals to lambda square t1 t2 plus lambda mean of t1 t2, and the autocovariance is c t1 t2 is r t1 t2 minus e of xt square. So this is equals to lambda mean t1 t2, and the mean of Poisson is lambda t, which a linear function of t. The autocorrelation function contains a terms of mean t1 t2, which comes from the property of an independent increment. And next is the Poisson increment process. The definition is with xt is a Poisson process and greater than 0 as a given constant. We could have a new process. Yt is equals to xt plus delta minus xt over delta. And the property, the first order probability process is pyt equals to m over delta is equals to e to the minus lambda delta, and lambda delta to the n, and where n is the number of cells in t to t plus delta, and the mean is equals to lambda, which is a constant, and the autocorrelation is for t1 t2 greater than or equal to delta, it equals to lambda square, and t1 t2 less than delta is equals to lambda squared plus this part, and the autocovariance is equals to 0 and this part. In the expressions of autocorrelation, this part is a triangle with area lambda, which is independent of delta. When delta goes to 0, the triangle becomes an impulse with area lambda. This is the pulsar impulse process. And now we can see the pulsar impulse process. The definition is dt equals to dxt dt is equals to lambda delta to 0 yt, where x is also a pulsar process. And the probability message is not defined, and it's not a definition. And the mean is equals to lambda, which is also constant. The autocorrelation is equals to lambda squared plus lambda delta t1 minus t2, and the autocovariance is equals to lambda delta t1 minus t2. The process dt minus lambda has a 0 mean, and rt1 t2 is equals to lambda delta t1 minus t2. So dt minus lambda is a white noise. And then the semi-random telegraph signal. The definition is that when xt is equal to 1, when k is even in the time 0 to t, and is equal to -1 when x is odd in the time t0 to t. The number in t1, t2 of the points ti in the interval t1 to t2 of length t equals to t2 minus t1 is a pulsar random variable with lambda t. We have the probability of n t1 to t2 is equal to k. This is equals to the pulsar process expressions. And the first order probability message is the probability of xt equals to 1 is equals to e to the lambda t, and e to the lambda t plus e to the minus lambda t over 2. And the probability of xt equals to -1 is equals to e to the minus lambda t plus e to the lambda t minus e to the minus lambda t over 2. And the mean is e to the minus 2 lambda t. The autocorrelation is e to the 2 lambda t1 minus t2 absolute. And the ct1 t2 is equals to e to the lambda t e to the lambda absolute of t1 minus t2 minus e to the minus 2 lambda t1 minus t2. The probability of xt equals to 1 is not half, because we start with +1, and pxt equals to 1 should be a little higher than 1 or 2. This goes to half when t goes to infinity, and ext goes to 0 when t goes to infinity, and the autocorrelation goes to 0 when t1 minus t2 goes to infinity. When t1 and t2 are far away, xt1 and xt2 are less correlated. And then let's see the random telegraph signal. The definition is let A be a random variable independent of lambda t, which p of A equals to 1 is equals to p of A equals to -1 is equal to 1 over 2. We can have a new process, yt equals to axt. And the first order probability message is pyt equals to 1 and pyt equals to -1, both equals to 1 over 2. The mean is e of yt equals to 0, and the autocorrelation is e to the minus R2 lambda, the absolute of T1 minus T2, and the autocovariance is also equal to this. This is equal to 1 second. Make us guess that YT may be a SSS process. EYT is equal to a constant. Also make us guess it is the SSS. And next is the random walk. See, the definition is that toss a fair coin infinite times. K is the number of heads in the tosses, and XNT equals to KS minus N minus KS. This is equal to 2K minus N. The first order probability message is PXT equals to PXNT equals to RS is equals to N minus R over 2, 1 over 2 to the N for this. And the mean is equal to 0. The autocorrelation is equals to to the mean NM, mean of NM as squared. And the autocovariance is also equal to this. From the probability message, we guess that when n goes to infinity, we have Gaussian density. The autocorrelation function contains a term mean of T1, T2, which comes from the property of independent increment. And the last one is a Wiener process. The definition is that it is a process as a limiting process of random walk. WT is equal to the limitation of S goes to 0, T goes to 0, N goes to infinity, XT. And probably the first order density function is F omega T equals to 1 over N squared 2a pi alpha T multiply with e to the minus w squared over 2 alpha T. The mean is 0, and the autocorrelation and the autocovariance is both equal to the mean of T1 to T2 alpha. We can know that omega W0 equal to 0. And the independent increment and the Gaussian increment, which is. So this is the problem 1.